right. Let me see. Can you all see my presentation?
Yeah.
Yeah.
Yes.
Yeah, great. Awesome. Then, yeah, welcome to this introduction tutorial to Dask, a Python library for distributed computing. I'll start with a little bit about myself. I mean, we talked a little already just now, but I live in the Netherlands, in Utrecht. I grew up in Beirut, in Lebanon, for most of my life, but was born here and now I'm back. I currently work as a data science evangelist at Coiled, which is actually quite a new journey for me. So I realized, I think last weekend, that I wrote my first Python code about 1.5 years ago, because in a past life, where actually my previous office was this place, I was a producer, project manager at a contemporary art museum, which was housed in the oldest monument of Amsterdam, a church building, and we kind of transformed it into big contemporary art installations. In this case, the artist that you see there in the foreground decided to cover all of the windows of that church with red filters for 6 months. So it was super intense. And a very different life to what I'm doing now. So I have a background in arts, architecture, and anthropology, but basically during lockdown, yeah, about 1.5 years ago, I decided to chase my curiosity for programming and tech and started learning some Python, and that kind of snowballed into doing a 6-month bootcamp, finding out about Dask and then Coiled, and then yeah, getting an internship there, and now I'm a full-time evangelist. So really excited to be here. You can find me on Twitter and GitHub and connect to me by email at the places mentioned there. And with that, I'd say let's jump in. So in the next 1.5 hours, we'll start with about 15 minutes of kind of building some intuition around Dask. We'll work through some code for about 45 minutes, showing the different ways that you can use Dask. And then we'll end with about 30 minutes of open Q&A and discussion. And what I hope that we can do in this kind of these 3 blocks is start by answering the question, what is Dask? Then spend some time looking at how you can use it, and then end really with answering any questions that you have, either about applying Dask to your own personal projects or in your company, or kind of talking about all the different alternative libraries for distributed computing and how Dask compares. We'll see where that goes. So to start, what is Dask? Dask is a flexible library for parallel computing in Python that follows the familiar syntax of the existing PyData ecosystem. Now that's a lot of words. You don't need to remember all of them, but at least remember parallel computing, familiar syntax, and flexible library. Those are kind of the 3 main topics that I hope we can dive into. And with that, I would like to welcome you to this year's Dask Car races, a very popular sports event in the PyData world. I'm sure you've heard of it before. And in this race, we have a number of different teams competing with different cars. We have a Pandas Race Car, the Numpy Race Car, Scikit-learn, XGBoost, Prefect, and X-Array. And there's many more, but we'll start with a small selection. Obviously, this is a little metaphor for the libraries that we all work with in the PyData ecosystem. And the great thing about these race cars is that even though a lot of engineering and hard work has gone into building these from scratch, you as the user, as the data scientist, can step into these and basically drive them off the lot. So you need to know how to operate them, right? You need to know the API, you need to know how to use the steering wheel and the brakes, but you don't really need to know much about the internal workings to use it and get value by solving business problems with these race cars. And just like different race cars from different teams, these libraries also have different things that they're good at or perform well at. And you wouldn't use the same car for every trip. You choose one based on what you need it for. So let's jump into one of these cars, the Pandas Race Car, probably one that's the most familiar to most data scientists, and have a little look at the race car, how it does. And well, this is me or you stepping into the Pandas Race Car. And the Pandas Race Car is great. I mean, we all use it often. It's really a foundational part of the PyData ecosystem, and a lot of hard work and time and energy has gone into really crafting it into a race car that looks good, that drives well, and that does what it is meant to do. But like all race cars, it can't do everything. It's got some limitations. And the specific one I want to talk about right now is what happens when you run into trying to use pandas for a data set that's bigger than your RAM or bigger than pandas can handle. So the Pandas Race Car is great for relatively small data sets. So this is a little more pixelated than I would want it to be, but if we try to import a large CSV with pandas, in this case, one of the 12 CSVs of the 2019 New York City taxi dataset, I think this is about 1 gigabyte. This works fine on my machine. It takes a little while, mostly to download the data from S3, but eventually this will complete in about 2.5 minutes in my case. And we can inspect the data and really work with this pandas data frame the way we would like to. Now, if we then proceed to try and load the entire data set, which is 12 CSV files, so we can use the glob character to download all 12 CSV files, which I think is about 12 to 15 gigabytes, somewhere in that range. In my case, this depends on your machine, obviously, but in my case, this errors out. So this data set is too large to fit into RAM memory. I think the rule of thumb with pandas is about 5 times. You need about 5 times the size of your data set in RAM to load it in comfortably and do everything that you want. So basically, the Pandas Race Car stops working here. And Dask exists to solve this problem. So that memory error, that sort of limitation of the Pandas Race Car, where it's like, okay, I can't go any farther, I can't handle this. Dask exists to move us beyond that, and thereby also solving many other problems that we'll see later. So to just zoom in a little bit more about into what we just did, we'll just take a closer look at kind of a sample workflow. I have to say it's really weird talking just the screen. I can't see any of you guys, so I feel like I'm talking into a void. But I think you're all still here, right?
Yep.
Yeah, great, good, awesome. Yeah, Pandas works great with a small data set, about 2.4 million rows. We'll see that Pandas errors out if we try to import a larger data set. And we can then see that Dask can handle that larger data set locally fine. And we can even scale Dask out to the cloud or to another cluster with the same code to handle basically infinitely large data sets. So let's work through this. We can use Dask data sets of time series to generate some synthetic time series data. In this case, 2.4 million rows. Write that to Parquet. So this should all look pretty familiar if you've worked in Pandas. And then we can read that data frame. We can read that Parquet file in as a data frame using the pandas.read parquet and get the number of unique values in a column. So relatively straightforward, no issue there. Now, if we use the same code to generate a larger data frame with 665 million rows, we'll run into the same memory error. So either you'll get the memory error or your kernel will restart if you're working in a Jupyter notebook. Pandas, again, is basically saying, this is too much, I can't handle this. Whereas Dask handles this fine. You can read in the same parquet file using dd.read parquet, and then use very similar API to calculate the unique values of that same column. And this is being done in parallel, which is why that works. And basically giving a very quick overview here. We'll dive into details and kind of peel apart the onion of complexity slowly. So yeah, Dask scales PyData libraries like Pandas, but not only Pandas, for distributed computing. So basically, what happened here is that we saw the founders of Dask saw the Pandas Race Car and thought, hey, this works great. People like this. People like this car. It drives well, but it's got limitations. What if we could put in a different engine so that it still feels the same, it looks the same. People can kind of transfer a lot of their skills of working with Pandas straight over, but we no longer have the limitations that the Pandas engine has. So we have the same car with a different engine, or in other words, familiar feel, but no more limits on data size by switching out the engine. So the founders, the authors of Dask did that with the Pandas race car, put in a Dask engine, and you get a Dask data frame. With the Numpy race car to get a Dask array, with the scikit-learn to get dask-ml, with XGBoost to get distributed XGBoost. And basically, with the creation of Dask, a lot of the Python tools that were not scalable to parallel computing could now be scaled. And so, yeah, this might mean that you've used Dask without knowing you've used it. So if you have run a prefect workflow, you might never have written any Dask code, but prefect is using Dask under the hood to run things distributed. The same with some of these other libraries that you see there. So again, just to reiterate, Dask scales PyData libraries for distributed computing. Now, when people see an engine, they often have one of two reactions. Some people are like, awesome, that looks great. I don't want to know how it works. I just want to step into this car, drive off, and have a great ride. Other people say, an engine, fascinating. I want to know how it works so that I can build my own race car around it, or a spacecraft, or any other thing, really, right? Once you have the engine, you can decide what to build around it. So for a very quick sneak peek under the hood, we'll just pretend that we are the person on the right. We're the mechanic. We want to know how this engine works. Basically, Dask works by creating task graphs. So when you submit a task to Dask, it'll basically cut that up into very small pieces, distribute those pieces over a number of workers who can execute those computations in parallel, and then bring back a single result to you, the user. And again, just giving a very high level overview intuition here. We'll dive into more details in a little bit. And yeah, you can have one of two reactions to this, right? It can be, well, this is scary, this is overwhelming, in which case you can shut the hood and just step into the car and drive. You don't need to know how this works. But it's also kind of exciting and cool to figure out, hey, this is happening in parallel. This is distributed computing. It's actually a whole different ballgame. And once you can kind of get the hang of this, you can also customize it, which is really powerful. So just to quickly sum up, Dask is an engine for high performance parallel computing. you can step right into the pre-built Dask race cars that the Dask team has built, the Dask data frame, the Dask array, or Dask machine learning, and you really need zero mechanic skills. But you can also take the engine out of the Dask cars to build your own race car or spaceship, or really whatever you want. So with that, my cool animation is not working the way it should. That's disappointing. But I'd say let's step into the Dask car and race off. If I've got some code that I'll bring up on the screen right now. If you want to follow along, you can go to this link. It'll take you to a GitHub repo. I am going to see if I can share that link with you all here. And then also switch my screen over. Let's see. All right. Can you all see my GitHub screen?
Yep.
Yep, great, thanks, Kevin. So that link should take you here. Yeah, and you can run this locally, or you can launch this in Binder. So feel free to, if you want to launch this in Binder, go ahead and click that now so that it has some time to spin up. I'll be working locally over here. And just, yeah, let me know if anyone has any trouble getting to that or setting it up. Otherwise, I'm just gonna dive straight in. Oh, and I think I posted the link. Sent it to Kevin instead of to everyone. There you go. All right. So let's take the Dask car for a test drive. Specifically, let's, yeah. So again, I'll kind of show you what the Dask cars can do, and then we can dive in a little deeper to look at what's actually happening. So to start off with, we have the first Dask race car is the Dask data frame, which is a Pandas car with a Dask engine. We can import Dask data frame as DD. We could run a little script here that we've written to download some data. And then, as you saw on the slides, we use dd.readCSV to read this in as a Dask data frame. And just like with Pandas, we can call head to get the first 5 rows. And we can execute group by computation, grouping by one column and getting the mean of another. And you'll note here that basically the only difference with Pandas is a compute call at the end, which we'll explain very soon why that's necessary. Then moving on.
Sorry, could you make your text a bit bigger,
Yeah,
maybe?
sure, of course. How is this?
Better.
Yep, great. Then, so yeah, but this is an example of Dask kind of superpowering Pandas. But that's not everything that Dask does. This is probably the main thing that Dask is known for, right? A lot of people say, oh, Dask is distributed Pandas, which it is. But that's not everything, because we have the Dask engine and we can slot that into a lot of other things, like the Numpy car. So Dask arrays is the Numpy car with the Dask engine superpowers. So we can import Dask array as DA, generate a Dask array with some random values. We're here giving it the dimensions of the array as well as the dimensions of the chunks. And this is, if you remember the task graph that we saw with all the little bits, basically Dask breaks large things up into small things, and then sends small things out to workers to be processed and then collects them back. So if we were working in NumPys and we just called the array, we would expect to see some of the content of that array. But if we do that with a Dask array, we don't get any of the contents. We instead get some information about this array. So the size, the size of it in memory, the shape, how many tasks it consists of, and some information about the chunks. So one big array, 10,000 by 10,000, is cut up into 100 chunks of 1,000 by 1,000. And we only, yeah, just thinking here, let's leave that there. Then we can slice on this array, but again, nothing really happens actually until we press, until we include a compute call. And this is because the only thing Dask really does, so sorry, let me back up a second. Dask works with something called lazy evaluation. So when you create this array, it doesn't actually generate the values. It doesn't actually create the array. It creates the sort of the recipe or the roadmap or the task graph that's needed to get to that result. And it will only compute the actual result when you call compute. And we'll see later why that is, but I think maybe for now, just keep in mind that Dask is lazy and won't compute until you specifically ask it to. So we can slice in this array, or we can sum along an axis, which is all very familiar if you've worked with Numpy. Then I'll just give you a sneak preview of one more Dask race car, Dask machine learning, which is the scikit-learn car really with Dask rocket fuel. So a lot of this API will look familiar if you've worked with scikit-learn before. We'll generate some fake classification data, which are Dask arrays. So again, lazily evaluated. We can instantiate a dask-ml estimator here, and then fit it basically, yeah, the same way you would do a scikit-learn estimator. And predict, score. I'm running through this quickly because I'm assuming this is familiar. If anyone has questions, feel free to flag. So these are examples of 3 sort of pre-built race cars that the Dask team has built for you, but you can also write your own custom Dask code and kind of create distributed computing patterns for your specific use case. So in this case, we're writing 2 functions, one that increments x by 1, and we're basically just telling this function to take 1 second to run. And then a function that adds a number of variables that we supply to it. So if we run this normally without Dask, Python will run this sequentially. So it will run x first, y first, and then z first, which will take 3 seconds because there are 3 functions, each of which takes 1 second. Now, x and y don't actually have anything to do with each other. You don't need x to calculate y, nor the other way around. So if we could run in parallel, we could calculate those together and then use the output of that to calculate z. And this is what Dask allows you to do. So we can import delayed from Dask, which is a function decorator. And we can use the same functions, just add the Dask delayed decorator to create delayed objects, which, just as we saw with the array before, doesn't actually contain anything yet. So whereas if we call z here, we should get a scalar. If we call c here, which is an outcome of a delayed object, we don't get a value yet because Dask hasn't run this computation yet. And you can do something cool. I hope this is going to work. Yes. With the visualize method on delayed objects, which shows you kind of a tiny, in this case, tiny task graph of how Dask is going to get from your input to your desired output. in this case, it's a function which is represented by a circle, leading to one output square. And the same for B, because they're the same operation, just with different input. Then let's see, I think what I wanted to do here. Sorry, I made some changes here last minute. If we do c.visualize, we'll see that C, which is our final product, is the product of A and B, which are then added together to give us C. And if we, yeah, and you might be wondering, okay, why isn't C just being calculated? Well, the advantage is, okay, let's say this is what we want C to be, but then we realize, hey, actually, I want to do one more thing before I calculate my final result. I also want to add D into the mix. You can do that. And because this value hasn't been calculated yet, Dask can just update the task graph and say, okay, I now have these 3 functions that I can run in parallel, and then bring those together to get the final value. So does anyone want to take a guess on how long this is going to take to run? I have 8 cores on my laptop, so. This will take 2 seconds because these 3 can all run in parallel. This one needs to wait for these 3 functions to be completed first. So this block here will take 1 second, and this will take 1 second. So again, this is kind of diving a little bit into the Dask engine, right? You don't need to know really how this works to use Dask data frame or Dask array, but it is helpful to understand what's going on. Now, if I wanted to, let's say, add 25 or 30 increment functions here in a row and add all of those up, and I still wanted it to take 2 seconds. If I work on my laptop, that won't be possible because I have only 8 cores. So I could maximum do 8 of these increment calls and have them still run in parallel in 1 second. But I could scale out to a cluster. And this is where Coiled comes in, the company that I work for. Coiled provides managed Dask clusters. So I've already spun up a Dask cluster here, but just to show you very quickly, with this Coiled.cluster API, we can spin up a Dask cluster, in this case with 20 workers. Can specify the software that all of these clusters have. You can also specify things like the number of CPUs, CPU memory, or worker memory. And we can then do operations that would not be possible. So this is, again, that same CSV file that errored out before. We can load this in parallel on our Dask cluster. And the cool thing here is that this Dask code really doesn't change based on where you run. So if I'm running this locally to test it out, it's the same code as when I connect to a Coiled cluster with 20 or 100 or 300 workers. The code is the same. Ricardo is asking, how do you set up the Coiled cluster? Basically, this is it. So cell 35. This is where you give your cluster a name. You say how many workers it has. You could add things like worker memory. Let's say 25. You can specify the software environment, which is something you have to create in Coiled before. And then maybe I'll just, we have a web-based interface where you can see the Coiled clusters that you have running and inspect their logs and things like that. Does that answer your question, Ricardo?
Yes, but also you have to create, an account in Coiled, right?
Yes, yeah, correct. So
okay.
and that's correct. Yeah, and that's as easy.
Okay.
Sorry, I forgot. That's what I do
Yeah.
every day. So that's as easy as signing in.
You
with
gave me
GitHub
one side of the
here.
coin. I want to see the other side.
Exactly. Sign in with GitHub here, and that's in your case all you'll have to do. That'll sign you up for the free tier, which will give you some resources to experiment and play around with. So thanks for clarifying that, Ricardo. Cool. So this is a very quick test drive. The next thing I'm going to do is kind of jump into more detail into the Dask data frame. But before that,
Richard,
any questions?
Richard, just one, just one comment. I asked because I've been working with with Spark, the other the other empire here in distributed computing, and let me tell you, it takes a while to do all that setup. Okay, so if you're saying that I just have to create an account with GitHub and then just copy this the script there, I mean it's fairly simple.
Yeah, we hope so. That's why we exist.
Yeah.
So I hope.
With Spark, it's a trip. It's a trip.
Yeah, and I think maybe this is diving in a bit deeper, but it can also be a trip with Dask, right? So Dask has and not with hopefully not with Coiled, but that's
right.
why we exist as a paid offering, right? So you can spin up your own Dask clusters without Coiled. And then you use something like Dask Cloud Provider or Dask Kubernetes, or there's a lot of open source libraries that will help you do that. But then you need to manage your own ways of installing the right software environments on all of the workers. You need to manage security yourself and all of those things. I saw a presentation at PyData Global last week where a financial company was talking about their in-house open source Dask deployment. I think they had a team of 5 or 6 people working on that. Coiled exists to kind of do all of that for you. It is our aim to make that as simple and smooth as signing up for an account and writing something like this. Yeah.
Excellent.
Any other questions before I move on? Cool. Yeah, this is, I think I'll just run through this very quickly. I've kind of touched on it a little bit at the beginning of my talk, but what is Dask and when to use it? Dask is a flexible library for parallel computing that follows the syntax of the PyData. So we've seen that, right? In the case of Pandas and Dask, similar API, but higher distributed capabilities. And yeah, we've started to have a look at this. So we have the main Dask APIs. There are 5 of them. The first 3 are kind of the pre-built race cars, the Dask array, data frame, and bag. The bottom 2 are kind of the lower level engine type APIs, Dask delayed and futures. All of these create task graphs. So they cut up your large computation into small parts and create sort of a roadmap for how to get from what you want, what you have to what you want in the most optimized way. That all of that is, the computation is delayed so that really when you call compute, when you know everything that you want, Dask can look back and say, okay, I know everything now I can optimize how to get there. And that optimization is done by Dask schedulers, of which there are 4. And I would suggest you only remember 1, which is the distributed, which basically, for all practical purposes, does everything that a single machine scheduler does, and actually has more, it's kind of the advanced scheduler with more diagnostics and all of that. So just a very quick sort of overview of the main components and concepts that are that you kind of need to know if you're working in a distributed environment. which is that you have a client, which is the place where you're writing your Python code. In this case, a Jupyter Lab session, could be an IPython session or something else, a Python script. That client is sending requests to the scheduler. The scheduler is what creates the task graph and what sends tasks, so little bits of data of work to the workers for execution. Yeah, the kind of the inception-y thing to remember is that this could both be happening locally on your computer. So you're doing distributed, but on one machine, in which case each worker is one of your cores, or a cluster in which each worker is a different machine or a different virtual machine. Any questions about this diagram? No. Then finally, when to use Dask. Yeah, there's a lot of use cases, but basically here we've provided kind of a simple checklist. Does your data fit in memory? If yes, most likely you're fine using Pandas or Numpy or whatever, or scikit-learn or whatever you're used to using out of the box. If it doesn't fit in memory, Dask can probably help. You can also use Dask to speed up computations that are working fine with Pandas or Numpy or regular Python, like we saw with the Dask delayed example. If something took 3 seconds, we could bring it down to 2. Of course, that's a small margin, but if it was 3 hours and you could bring it down to 2 hours, that would be a lot better. And basically, yeah, this is kind of a helpful diagram to think, okay, if you think in terms of data size, on the x-axis and model size, it says in this case, or kind of computational complexity on the y-axis. If you're in this first quadrant on the bottom left, you don't really need to use Dask. Your data is small, fits in RAM. Computation is not super complex, doesn't take too long. You're probably fine just there. Anything else? So when things get compute bound, memory bound, or both, Dask can help you out. All right, the Dask data frame. I think we've kind of illustrated. Actually, I think I might do a little poll because we have 15 minutes or 20 minutes or so of code left to walk through, and I have quite a bit of material. Do we want to dive into Dask data frame further, or is there more interest in diving into how Dask can help with machine learning? Or do you want me to do a quick run through of the data frames and then go over to machine learning? Yes to data frame. Okay, great. I will do that. Cool. So again, just refreshing, Dask data frame is basically a Pandas data frame, but scaled up for larger data sets. So Dask becomes useful when the data set you want to analyze is larger than your machine's RAM, where you would normally run into a memory error. So we're gonna download some example data, which in this case is only 200 megabytes. So technically we could work with this in Pandas, but we're doing that just to kind of speed things up. You could scale this up to 20 gigabytes or larger if you're working on a Coiled cluster. It's really infinite. So we can go ahead and run this script, which will download some data. This is basically what we saw before. In the quick test ride, we read in the files using dask-dataframe.read CSV. And yeah, maybe it's helpful to show quickly the docs for Dask read CSV. So yeah, the docs say this parallelizes the Pandas read CSV function in the following ways, and internally uses Pandas read CSV and supports many of the same keyword arguments. So really, for most practical use cases, you can expect to transfer over the same pandas keywords and all of that. With a caveat that working in distributed is really a different game. So not everything works exactly the same way, but the Dask docs should guide you there as well. And one of those differences that you'll see is if we call this data frame, kind of the same with what we saw with the array. If we would do this in Pandas, we would get some contents of this actual data frame. But here we get kind of this weird, what is this, empty sort of schema structure, where we have the column names, we have some information about the data types, and we have something called n partitions, which in this case is equal to 10. So this doesn't actually contain any data yet. And this is, if you remember, because Dask evaluates lazily. So it knows how to get to the contents when you really want them, but it won't load them into memory until you specifically ask for it. What it has loaded into memory are the column names, the data types, and the number of partitions, which in this case is 10. And this is where it gets interesting. So this Dask data frame is cut up into 10 partitions. And every Dask data frame is cut up into a number of partitions, where each partition is small enough to fit into your memory. And because it fits into your memory, it can be a Pandas data frame, and it is. So a Dask data frame is basically a collection of smaller Pandas data frames. And this is why the Pandas API can be copied, because basically under the hood, Dask is applying Pandas functions to Pandas objects, lots of them, and bringing back, it's kind of synthesizing all the results of those Pandas operations on Pandas data frames, and then bringing it back. I think I have covered most of that. So we can also call visualize on this data frame. And we'll see that it's basically the result of calling read CSV 10 times to create the 10 partitions. And this, depending on how many cores or workers you have, if you have 10 workers, they could happen exactly in parallel. If you have 4 workers, then the Dask scheduler will say, okay, run these 4 first, then run the next 4, and then when workers free up, the Dask scheduler is kind of orchestrating when workers are free to receive new work and so forth. And just like we saw before with Pandas, you can copy you can use the head method to inspect the first 10, in this case, rows of this data frame. And head under the hood, like implicitly calls compute. So when you're using head, you don't need to explicitly call add a compute to the end, which you do have to do in most other cases. So yeah, let's look at some kind of common computations with Dask data frames. Let's start by trying to compute the largest flight departure delay in this data set. So it's a data set of flight departures from New York City, an airport, or maybe actually some airport in New York. In Pandas, we could do this by iterating over each separate file that we have, load that into a Pandas data frame, then find the max departure delay of that file, append that to a list, and then find the max of all of those individual maximums. With Dask, we can use Pandas-like code to do this. So we can say, okay, this is a Dask data frame object. This departure delay column, find me the max, and store that in the max delay variable. Now, again, if we did this in Pandas, this would give us a value, but because it's Dask, it doesn't compute it until we specifically ask it to. Now, I'm going to call visualize on this. And that's kind of starting to show the complexity of what's going on under the hood when Dask is doing things distributed. So these are each of the 10 partitions which are in parallel, reading a CSV, getting an item, and then finding the max value of a series of the column that we asked it to. This returns a result. These results are then all stored into one object, and the max of all of those results is what is returned to us. And so Dask has created this task graph, but it still hasn't computed the value until we specifically ask it to, which in this case is 1,435, and I think that is minutes, which is about 24 hours. Pretty long delay. So there's some other examples here of pandas-like computations. Yeah, I think you can run through these for the sake of time. I'm not going to run through all of these, but basically the message is the same. This is all very familiar Pandas API, except for the fact that you have to call compute at the end. Any questions here? If not, I will move on to.
Richard, I have one quick question. What is
Sure.
the limitation on the cores? The number of workers. If you are running local. Because you're saying about the number of cores, or you can expand that.
No, the number of workers is the number of cores. Yeah.
The number of cores. Okay, got it.
On your machine. Yeah.
Okay, exactly. Okay.
If you're running locally, obviously. Yeah.
Sorry, can you set a limit to that? Let's say your machine is running 4 cores. Let's say I just want to use 2. Can you?
Absolutely. Yeah. So that's a good one. Thanks. That reminds me that I had more here than I thought I did. I'm going to say a little bit about the scheduler. So I mentioned earlier at the start that there are 4 different schedulers in Dask, but basically just remember one, the distributed. And up until now, we haven't actually used that yet. We've sort of implicitly been using the single machine scheduler. But basically, whenever you want to write Dask code, I would advise and recommend that you work with the distributed scheduler, which you create by importing a client object from distributed, which comes when you along with you when you install pip or conda install Dask. And then you instantiate a distributed scheduler by instantiating this client object. And from there on, this kind of creates a local cluster and does that by default using all of your cores, but you can give it an n workers keyword argument to say, hey, I actually want you to use only 4 or only 2 or up to you. And once you've instantiated this object, from here on, it'll use the distributed scheduler for any Dask computation you do in that same Python environment. Is that clear?
So Richard, is this analog to the in scikit-learn? You can do the n underscore jobs, equal to how many cores, more or less. This is the same,
This is similar. Yeah.
Okay.
So we'll actually see the n jobs in the next notebook, but
okay.
This is the same. And this is because I had another scheduler running. You can ignore those, that red box. If you have a distributed scheduler, the distributed scheduler also comes with a dashboard, which gives you really cool insight into your computation as it's running. So it opens, you get a link here. And if we now run this computation, this is a Dask computation, this will run with the distributed scheduler. And we can follow along in the dashboard. Now, this is a very quick very quick task, but we'll see a longer one in a little bit, where I'll kind of go into more detail about what you're seeing here. But basically, I've got 4 workers. I can see how many bytes are stored in each. These are the tasks that are running. And this is sort of really low level. Again, this is kind of the engine world. If you don't want to dive into this, you don't have to ever look at it. But I personally like to geek out on it because it offers a lot of optimization potential too, right? If you can figure out which tasks are taking longer, you can tweak your code. It's good practice at the end of a Jupyter Notebook when you're done using the Dask client to close it using this API. All right, so I think the idea was to have 30 minutes for questions and discussion. I think I'm running up to that time. Do we want to take a little more time to look at machine learning? Let's say maybe 5 or 10 minutes, and then have 20 minutes left for discussion. Is that Kevin? What do you think?
That sounds good, I think. Yeah, we can do that.
Okay, cool. Yeah, so by the way, this is normally a tutorial that we do in about 2.5 hours. So I'm really going, I'm aware that I'm going fast. So feel free afterwards to reach out and ask questions. I mean, all of this material will be available for you. But yeah, I also kind of want to demonstrate all the different ways in which you can use Dask, is actually Dask speed. Cool. So yeah, we saw this diagram before. Depending on your data size and your model size, you might want to use Dask if you're memory bound or compute bound or both. And there's a few different ways that you can use Dask for machine learning. So yeah, normally I do a kind of quick run through of a basic scikit-learn workflow. I'm going to do this very fast. Basically, this is scikit-learn sort of vanilla without Dask. We can make some synthetic classification data, look at the 2 arrays, import in the support vector, classifier, and fit it using the scikit-learn API. Look at the support vectors and score it. And if we want to figure out the best hyperparameters to use, we can do something like grid search CV, which trains our model on all the combinations of the parameters that we give it. In this case, doing 2 folds for 4 parameters, which is 8 fits. And as you can see here, it's training each one of these 8 fits sequentially. So it does the first one in 3 seconds, and the next one, and the next one. And that'll take 14.2 seconds. Once we're done, we can get the best parameters and the best score. Now, as Ricardo already pointed out, some scikit-learn algorithms come with a njobs keyword, which is using something called joblib to give us parallelism on our laptop. So joblib sort of, in a way, does what Dask does, but specifically for scikit-learn. And only locally, so it's a very important distinction. But if you're only working locally and you're working with an estimator that has the njobs keyword, you can say, okay, njobs equals to -1, and this will train or fit the models in parallel. So as you'll see, this won't give a sequential thing because it's not running sequentially, it's running in parallel. And I think, yeah, that takes about half of the time. So this is already possible with joblib, but only works locally. If you're working with multiple machines, either on a Coiled cluster or a Dask cluster that you've built yourself, you can use something called the Dask backend via joblib. So basically here, Dask and scikit-learn, the OSS teams collaborated to figure out a way to get these algorithms that have the njobs keyword to scale across multiple machines. And yeah, you might be wondering why does that need work, right? If joblib already exists, why can't joblib just work over multiple machines? That has a lot to do with things like timing, like which, not every machine is running on exactly the same clock, and things that happen with data transfer across multiple machines. So basically, things get a lot more complicated when you go beyond one single machine. And Dask had figured out a lot of those things already to create Dask data frame and Dask array, and those same things could translate over to creating sort of a distributed backend for scikit-learn. So here we'll create our distributed client again, and we can now, let's create kind of a bigger parameter grid since we're working in distributed. I'm actually gonna, well, let's just leave that. And create a cross-validation grid search. And now to use Dask instead of joblib, we import joblib and create a context manager and say with joblib.parallel backend, and we select the Dask backend. We can fit this model, which is 72 fits, which is quite a few. And if we open up the dashboard, this will take a little bit longer. So I have a little bit of time to talk about the dashboard. What we're seeing here is our 4 workers, which have 4 gigabytes each. And you can see how many bytes are stored on each. And here we can see the tasks that we're processing kind of in real time. And here we can kind of look in more detail about each task. So basically this is that task graph, which I wonder if no, okay, that's not going to show up, sorry. But that task graph that we saw before with all of the little bits, this is kind of the dashboard that's keeping track of what is completed and giving you information about how long each task took. Something went wrong here. Interesting. This was working before we started this call, and I think it actually also completed. So I apologize. I'm not sure what's going on there, which is the worst answer when you get an error like this. Yeah, but this should just work without problem, and I think it did. So I think this might be because I tried to open the task graph and something went wrong there. So that's an example. To kind of go back to the diagram we had at the beginning of a compute-bound problem, right? Our data set fits into memory. That's not the problem. But we have so many models that we're trying to fit. We're trying to speed that up by doing that in parallel, so that we can fit 72 models, not one at a time, but in parallel. Now, if we get to the memory-bound sort of realm, we'll need to do something else, because then we can't just use scikit-learn with the njobs keyword, but we actually need to break up our data into smaller bits and distribute both the data and the training of the model over a cluster of workers and then bring that back. And that is where dask-ml comes in. So dask-ml is a library you can install from conda or pip, which mimics the scikit-learn API, except in distributed. So this will look very much the same as scikit-learn. We can make some synthetic regression data, specifying the chunk size of our array, and instantiate a model. We can fit it, predict and score. And this will take, again, we can kind of look along here. This will take a little while to run. But we'll complete eventually. I think this takes a couple of minutes. I'm actually going to stop this right now and just move on because we're kind of running short of time. And show you that if you want to speed this up even more, if you're saying, okay, that's great, this is running in parallel, but I'm really in a rush. Maybe this is taking 2 hours and you want it to take 10 minutes because you're doing quick iterations. Instead of running it locally in parallel, we could connect. That is annoying. We should be able to connect to our Coiled cluster. Wait, that's because I logged out. Let's see. All right, James has to head out. See you, James. Thanks for watching. Let's see if this will work. Yes, great. So Ricardo, to finish the story of how do I get this to work, you also need to authenticate your wherever you're running your Python code with Coiled, which you do with Coiled Cloud. I had already done that, which is why I didn't have to do it. But when you sign out of this interface, it refreshes the token, which is what I'll do soon. So you can't all log into my account. But then because I gave my Coiled cluster a name, remember when we started it up earlier, I can refer just to that name and it will connect to that cluster, which was still running. So even though I closed the client and kind of shut off the connection from my Jupyter notebook side, the cluster kept running because I told it to. You can also tell it to shut down on purpose or automatically. And let's see, this should work now. So now basically what we've done, instead of creating a local client, which we would do like this with just calling client, we're now creating a client object, and passing it the cluster object, the Coiled cluster object. And this will automatically defer any Dask computation to the Coiled cluster. So if we now make this regression data again, and this is the same amount of data that we saw before. If we call fit, we'll see here that this has a lot more workers. I think this has 20 workers. I think each worker has 4 threads, if I'm not mistaken. So you actually have, or maybe 2, judging by the looks of this. So we have 40 kind of CPU cores working in parallel here. Which is of course going to go a lot faster than working on the 4 single thread cores that we had locally. So this takes about 17 seconds. And the other one, was I think about 2 or 2.5 minutes. So yeah, that is I think where I will leave it for now. There's more sort of notebooks. Number 4 and 5 are really kind of diving deeper into sort of the engine side of Dask. So working with Dask delayed, which is kind of the foundation of everything we've seen, but you don't really need to know it if you don't want to build your own stuff. But if you do want to build your own stuff, then the great thing about Dask, unlike things like Spark, is that you can really sort of take out the engine and pull it apart, take the little mechanics that make it work and build your own thing out of it. And that's essentially what an organization like Prefect or Xarray have done is they said, hey, this engine is great, but I want to build something else around that. And that's totally possible. So with that, I will leave it here for now. And let's let me know if anything was unclear, if you want me to talk some more about something specific, or if you'd like to bring in a question from your own work or experience. The next 20 minutes are really up for grabs.
Can you hear me?
Yeah.
So let me understand this. So basically Dask is basically a computing engine, right? That focuses on a niche Pandas specific statistical package, because Pandas is basically limited by how much data you could process. And considering times nowadays days with machine learning and the vast amounts of data that's available to us now that we can process and make all kinds of, I guess, I don't know, do all kinds of things with that data to basically do a lot of analytics. So what your task basically is, it's like an API. Both you have the distributed part, and then you also have, I remember you said correctly, what was the other part? There's two parts to it. There's a distributed parallel processing. There's another part that is associated with Pandas or any sort of Python-based library. And basically it's just, it just increases the processing power, really. Just a computing engine. And that's all really what Dask is, right? But it's somewhat limited, is it not? As far as like the statistical packages available, but it just focuses on Python, that PyData.
Yeah, so I mean, Dask at the moment is limited to processing Python code, but it would not be a lot of work. And there are, there's work in the Dask repository, at least to kind of scope out what it would take to run other code on Dask clusters. But I'm not totally clear on what your question is.
Well, it wasn't really a question. I was kind of
okay.
I kind of understood it. I apologize. I was just trying to clarify the point.
Sure. Yeah. No, so I think that's correct. Like that Dask is essentially an engine for distributed computing that has sort of that the Dask team has used to build some sort of race cars around like the Dask data frame and the Dask array, which allow you to continue to write basically Pandas or Numpy code, but scale up your data sets infinitely, or scikit-learn, or things like that. Same with XGBoost. Or you can sort of, and we didn't really get into that today, but you can kind of take the engine and say, hey, I've got this custom piece of code. I need it to run faster, or I need it to sort of be able to work with terabytes of data. We have at Coiled, we have a number of mostly financial customers like Capital One and hedge funds who are doing very complex analyses on time series forecasting on financial data that really go beyond the kind of simple map reduce problem. I mean, I can pull up something in the meantime. Let me see. Bring this here. So if you look, can you see the presentation?
Yes.
I think so, right? Yeah. So this is kind of a typical MapReduce kind of Spark workflow. This, no kidding, is a visualization of one of our customers' kind of custom built Dask workflow, right? Where you're doing one thing that might need to change, but only need to change if that other thing is changing at the right time, and then link to this other thing. So this is, I mean, I kind of avoid showing this stuff because it's also overwhelming. And there's also a very sort of easy way to step into a Dask data frame car, drive it off the lot. Never think about this. But the power of Dask really lies in the flexibility that it offers, because it has this the Dask delayed and the futures API, which is really the low-level kind of engine level of the code that's open and exposed, and that you can work with.
Yeah, I want to add to that. So I've used Spark and Dask like a bit myself, and Spark is heavily tied to the right now with Spark 3.0 and above. They are heavily tied to the data frame concept, which is what this slide is showing with the MapReduce. Like it's really the code is all about data frames and Spark data frames, whereas Dask, like what Richard showed, there's the Dask array, Dask data frame, Dask bag. The bag is the interesting one. Like you can deal with a lot of like JSON data and like MapReduce over JSON data without coercing it to a data frame. You can pass in arbitrary Dask functions to the scheduler and delay the execution of them, like what he showed with the Dask delayed. You can't do the same with Spark.
Yeah, that was actually something I was going to ask about with Dask bags and like large API consumption. and just breaking out your target so you can have it as a RAID like query. So you just have workers that are hitting 100 individual objects. I don't know, you know, some type of parameterized, you know, so that the distributed nature speeds up the query.
Mm-hmm.
Do you guys see that? Is that are bags kind of a niche edge that's being explored, or is it?
It's definitely niche and it's definitely being explored. Yeah. So I think yeah, I mean, we did a kind of a big at Coiled, we did a big Stack Overflow sprint a couple of weeks ago where we just went in for a whole week and answered any question tagged with Dask. There were not a whole lot of questions about Dask bag in there. But my intuition is that that's also because those people, people that use Dask bags, yeah, I think takes, yeah, it's a little niche and takes, yeah, it's kind of, it's not as easy, let me say, as kind of stepping into the Dask data frame when you know pandas already. So it's kind of a different object, but it does allow for a lot more flexibility. So it's definitely, I mean, I've used it myself to kind of load in a bunch of unstructured JSON data from the GitHub archive and
Nice.
store that as a parquet and just kind of, yeah, just kind of ETL with JSON data is one use case where that's very, very useful. Yeah.
Sweet. Thanks.
Yeah, no worries.
I was at the webinar with the Dask, where the Dask CEO, sorry, Coiled CEO, Dask project founder was speaking, and he did say Dask bag is like the least loved feature across the Dask ecosystem.
I know the black sheep.
Yeah, but it's just powerful because it can just be so irregular.
Yeah, exactly. Absolutely.
Yeah, it's really the applications. It's exciting for my work, but thanks, guys.
Yeah, yeah. Okay. Can I ask what do you why is it exciting? What would you imagine using it for? Just curious.
Oh, well, I could think of one with forward networks. Their NQE, like network query engine. There's sometimes huge data sets, so the analysis of that takes forever. But if I can lower it by just doing a subset of hosts, so just 100 hosts, and then send it through that same query rather than every device, then I can drastically speed up, you know, my results, and I don't have to sit there for 10 minutes.
Sure. Yeah. Cool. Sweet.
Yeah.
Well, yeah. Let me know if you ever want to give that a try with a Coiled cluster, and I can make sure you have enough resources.
Definitely. Thanks, man.
Yep.
Oh yeah, do you want to speak about the Coiled free tier, Richard?
Yeah. So I mean, I hope that was clear from my answer to Ricardo. But if you go to cloud.coiled.io and sign in there with your GitHub credentials, that will give you basically a page like this, which will have the login token that you need to authenticate from within your Python session. It's been a while since I don't know what the current state is of how many credits you get, but I think it's something around, yeah, it's a couple of hours of compute for sure. Yeah, if you're looking to do specific things and running into limits, just hit me up and I can talk to sales and bump up the limit for a month or two or something like that. If you're just kind of testing something out. Yeah.
Oh, hi everyone, this is Faye. I just have a quick question related to like cluster configuration and setup. Do you have some specific recommendations? So currently I'm a PySpark user, mostly using Databricks. So my data engineer team, actually, they are responsible for like how to set up cluster, how many workers, and do they do like auto scaling if you have shared resources or like high concurrency, like this type of situation. So I wonder, are there any specific features for like cluster that can do some sort of optimization to fit in the workload?
Yeah, that's a great question. Yeah, that's one. It's a question we get a lot, and I think there's two ways to answer it. There's a lot of ways. One, there's a lot of ways to customize your cluster. So maybe I would suggest starting to. I mean, if you're curious how to to know how to do that, I would suggest starting to have a look at the Coiled docs, where you can see all the kind of the hardware resources you can specify. You can see the software environments. You can look at. I mean, if I go back, just make sure I go to the right one. You know, here you can specify whether it shuts down when your Python process closes or not. You can specify the idle timeout that's by default set to 20 minutes so that you don't incur any unnecessary cloud costs. So there's a lot you can specify and customize. And you can go even deeper with sort of Dask code. As to sort of one size fits all the best way to do it, I don't have an answer to that question because that really depends on what you want to, what kind of computations you want to run. So it might, you know, in some cases you want a lot of workers, but they don't necessarily need to have a lot of memory or a lot of CPU cores. And other cases it might make more sense to have less workers, but increase the memory. That really is kind of impossible for me to say without having a sense of what code you're wanting to run. But again, if you, I think, let me bring up this slide. The Coiled Slack is a really great place to ask any of these questions. We have, if I'm not mistaken, 6 of the core Dask maintainers on our staff who are within reach to answer any questions like that. Faye, so if you're kind of, if you drop a message there with kind of what you're trying to do, I can tag the right people and make sure we get you some answers within a day or two. And so that's, I mean, that's a really great resource because the people who are building Dask, including Matt Rockman himself, are in that Slack. So there's no better place than the source to ask those kinds of questions.
Sure, thank you so much.
You're welcome. Yeah, and one other thing I would like to share, if you're interested in kind of learning more about Dask, Coiled offers a 4-day, well, it's 4 half days professional training course, which you can find at coiled.io/training. We're currently offering 50% discount for the next session if you use the early bird keyword or coupon code or whatever it's called. I did, so I'm quite new to this myself, as I said at the beginning, and I took this course myself I think a couple of weeks ago, and Adam, the person who gives it, is absolutely fantastic and another great resource. So I think, you know, this at 50% off, if you can get, if you're interested in using it, this is really a bargain. But obviously only if you're interested in using Dask professionally, probably. Any other questions, things I can expand on?
Okay, I guess if there are no more questions, then I mean, going once, going twice. Okay, since there are no more questions, thank you so much, Richard, for joining us.
You're welcome.
The presentation will be uploaded, and then if you want to contact Richard, he shared his contact information also. I don't know if you want to type it in the chat also, Richard, just so people have it.
Yep.
All right. And thank you for coming, everyone. We'll see you some other time.